Welcome to The Explainer. We talk a lot about what AI does, but today we're going to tear it down to the studs. We're building a complete blueprint from the ground up for the entire tech stack behind modern AI. I mean, everything from the actual silicon chip all the way to that smart agent you're talking to on your screen. So, how do we even begin to wrap our heads around something this complex? Well, let's try something different. Forget about lines of code for a minute. Think construction. Because that's really what this is. We're asking, how do you actually build the tallest intellectual structure humanity has ever seen? And that's where our central idea comes in today. We're going to think of AI as a skyscraper, a massive, towering structure built layer by powerful layer. We're going to start our journey way down in the subbasement, at the physical foundation, and climb our way up floor by floor, all the way to the penthouse suites where the AI actually interacts with us. So, here's the blueprint for our tour. We'll lay the foundation, build that digital brain, power the whole thing up, check out the applications in the penthouse, and then finally, we'll take in the view from the very top. All right, first stop, the foundation. You can't build a skyscraper on sand, right? And for AI, the foundation isn't concrete and rebar. It's raw physical power. We're talking about silicon, a ton of heat, and data moving at, well, pretty much the speed of light. And right at the heart of that foundation, you find the machine itself. Take a look at this, NVIDIA's upcoming Rubin platform. What's so wild here is this idea of extreme co-design. It's not about making just one part faster. No, this is about designing the GPU, the CPU, and the memory to work together in perfect sync. The Rubin GPU, for example, is slated to have a mind-boggling 22 terabytes per second of memory bandwidth. That's not a highway for data. That's like a teleportation system. So what does all that fancy co-design get you? Well, it gets you this. A projected 5-fold leap in performance from one generation to the next. And here's the key. It's not just about making the chips smaller. It's about inventing totally new ways to represent data, these new formats that let the hardware squeeze out every last drop of performance. Okay, but there's a catch. A big one. All that power, all those calculations happening billions of times a second, it generates an insane amount of heat. We're talking about a fundamental problem of physics here. You generate so much heat that you risk literally melting the foundation you're trying to build on. And that means cooling is no longer some boring detail you think about later. It's now a central pillar of the design. We are way past just blowing air with fans. The new standard is liquid cooling. Either pumping coolant directly onto the chip, or, get this, dunking the entire server into a bath of non-conductive fluid. It sounds crazy, but it's the only way to keep these AI data centers from cooking themselves. Okay, last piece of the foundation, the network. How do you get thousands of these super-powered chips to talk to each other and act like one giant brain? You need a data superhighway. And right now, there's a big fork in the road. You can go with InfiniBand, which is like a private, perfectly paved racetrack, super fast, super reliable, but super expensive. Or you can go with the Ethernet-based option, ROS. It's cheaper, more flexible, but you really have to tune it carefully to avoid digital traffic jams. It's a huge strategic choice. All right, foundation's poured, the lights are on. Let's head up a few floors. Now we get to start putting up the steel beams, the core structure of our skyscraper. The digital brain. This is where we take a mountain of raw data and start turning it into actual intelligence. You've probably heard garbage in, garbage out. And for AI, that's the absolute truth. You can't just scrape the whole internet and call it a day. The data has to go through this intense 5-stage refinery process. It's like panning for gold. You clean it, you sift out all the identical-looking rocks, you filter out the junk, you even use a little tester AI to see which bits are the most valuable, and then you do a final check to make sure you didn't accidentally include the exam questions in the study guide. Okay, so with our pristine data, we need a blueprint for the brain itself. The old way was what we call a dense model. Imagine an office where every single employee has to attend every single meeting about every single topic. It's not efficient. The new hotness is this mixture of experts architecture. Now you have a smart receptionist who reads an email and routes it to the right specialist, the legal team, the marketing team, whatever. It's a way smarter way to build and train these massive models. Okay, so the main structure's up. We have a digital brain. But right now, it's just raw potential, kind of like a building with no plumbing or electricity. The next few floors are all about the interior finishing. This is how we turn that raw intellect into something that's safe, efficient, and actually useful to people.
See, a freshly trained model is like a super smart genius who has read every book but has zero social skills. It knows a ton of facts, but it doesn't know how to be helpful or, not weird. That's where alignment comes in. First, we teach it to follow instructions. Then, we have it learn directly from human feedback, kind of like a hot or not for its answers, to fine-tune its behavior. It's basically sending the AI to finishing school. Now, the problem is, these fully educated, top-of-the-class models are enormous and cost a fortune to run. So how do you make them practical? Well, with a clever trick called knowledge distillation. It's literally an apprenticeship program. You take your giant genius teacher AI and have it train a smaller, nimbler student model. And the student doesn't just copy the answers. It learns the reasoning, the process, the way the teacher thinks.
And does it work? Oh yeah, the results are just staggering. You can take a huge 8 billion parameter model, shrink it down by half, and it still keeps over 90% of its smarts. This is the secret sauce. This is how we get powerful AI that can run efficiently on pretty much everything, from servers to laptops. Last step on this floor, the engine room. You've got this amazing AI, but you need an engine to actually deliver its power to the wheels, right? And it's not one size fits all. Think of it like this. Some engines are like a heavy-duty truck engine, built to haul the maximum amount of traffic. Others are finely tuned Formula One engines, all about one thing: speed. Getting that first response back to you in the blink of an eye. All right, take the express elevator with me. We're heading to the top, the penthouse. This is where the AI gets its corner office with a view. It's where it connects to the real world, where it can access private information and actually start doing things. And just like in any major city, this is also where you run into the zoning laws and the building codes that say what it can and can't do. One of the biggest headaches with AI in a business setting is that sometimes it just makes stuff up. We call it hallucinating. To fix this, we use a technique called retrieval augmented generation, or RAG. It's brilliant, really. It's like giving the AI an open book test. Before it answers your question, it has to go look up the information in a trusted private database. This whole system relies on super fast search tech to work. But here's the reality check. It's one thing to build a flashy demo. It's another thing entirely to build a reliable product that a business can depend on. In fact, Gartner thinks about 30% of these projects fizzle out after the cool demo phase. And that's exactly why this whole new discipline called LLM Ops has popped up. It's the boring but essential stuff, managing costs, security, and just keeping the lights on day after day. And of course, the more powerful this skyscraper gets, the more the city planners, the regulators, start paying attention. And what we're seeing is a huge clash of philosophies around the world. In one corner, you have the EU, which is taking a very strict let's protect people's rights first approach. And in the other corner, you have the US, which is much more focused on let's innovate as fast as possible to stay competitive. It's a tale of two very different building codes. So here we are. We made it to the rooftop observation deck. From up here on top of the modern AI skyscraper, you can see the whole city, the entire tech landscape. But look over there on the horizon. The cranes are already up for the next skyscraper. And the blueprint for that one, it looks totally different. The next 5 years aren't just an upgrade, they're a paradigm shift. We're talking about AI not just being an app, but being the entire operating system. We're on the verge of giving robots actual physical common sense. We might even throw out silicon chips and start computing with light, which could be 1,000 times more efficient. But honestly, the biggest game changer of all, AI is about to start designing itself. And that brings us to our final, really mind-bending thought. We just spent all this time walking through the skyscraper that we built. But what happens when the building starts building itself? When AI automates its own R&D, designing its own chips, writing its own code, what on earth will that next skyscraper look like? And will humans even be the architects?